Hi everyone, and welcome to our Q3 What's New in SAP HANA Cloud session. My name is Susan and I am part of the product management team for SAP HANA Cloud. As we only do have a limited amount of time today, we will only cover a few of the innovations we delivered with the Q3 release of SAP HANA Cloud. So if you want to get a comprehensive overview, definitely make sure to check out our technical documentation that is linked later on in the presentation, as well as our overview blog post by my colleague Thomas Hammer. As always, I'm not alone in this webinar. I do have a couple of colleagues with me who are supporting me in the back end and who are also diving deeper into the innovations that are delivered in their specific area of expertise. With this, let's just have a look at our agenda for today. As always, we're starting with a general update, and then we're actually coming to one of our key innovations for the Q3 delivery, which is the support for PrivateLink on AWS. Next, we're having a deeper look into the area of modeling, followed by an update from our multi-model colleagues. Another highlight we're having as part of our webinar today is the SAP HANA Tooling in BOSS, where we, for example, enrich the Database Explorer with GenAI capabilities. And last but not least, we're having a look at the enhancements in the tooling area. So let's jump right into the general section of the webinar, starting off strong with our first innovation. With Q3, we delivered the compression for data, log, and catalog backups. So once you upgrade your instance to the QRC 3 2024 release, the newly created backups will be compressed and they will gradually replace the old uncompressed backups. What is the result? Your customers will observe continuous reduction in the amount of the backup storage that is used each day until all the old and uncompressed backups are replaced by newer and compressed ones. This, in the end, eventually leads to reduced storage costs and to an increased customer satisfaction. Next on my list, we do have the integration of S4 data into HANA Cloud via DataSphere. So today's businesses strive to make data-driven decisions. They want to record across business functions and therefore need to integrate data across systems. So good news, with the Q3 release, we're offering a guided setup of DataSphere for replicating data from your ERP system to SAP HANA Cloud. Please note, as shown in the picture on the top of the slide, the Cloud Connector is only needed if you're using S4 HANA on-premise or S4 HANA Private Cloud Edition. If you're using the Public Cloud Edition, you don't need the Cloud Connector. So if this made you curious, I can definitely recommend to check out our Discovery Center mission, where you can set up your replication flow step by step. So definitely start your integration today and make data-driven decisions in your business context easier than ever before. So from data integration to migration, on the left side of our slide, you can see the different steps of a migration. And within the execution step, you can now, with the Q3 release, choose between standard and downtime optimized migration. So if you're choosing standard migration, or the standard migration in general is more suitable if you do have source databases that are under a high load. But if you do have a use case that is downtime sensitive, you might be looking for a migration scenario that is optimized for less downtime. And now we're definitely supporting this with our self-service migration tool. You can migrate your data and the delta changes while your business remains operational. And then the remaining delta changes and the catalog are migrated during your scheduled downtime. So this allows you to migrate and still keep your business processes running during the migration. With this innovation, we're supporting not only the standard migrations, but also the ones in a case where the use case is downtime sensitive. So definitely really, really nice to have a look into if you do have a downtime sensitive use case. From migration to security in the area of data privacy and protection, we do deliver 3 key innovations with the Q3 release of SAP HANA Cloud. First, you can now restrict user connections based on the authentication method they are using. So you do have a more fine granular security configuration option, and you're also having an improved protection from attacks from the internet. Next on the list, within the X509 format, you can now make use of wildcards when matching certificates. If this sounds a bit confusing in easy terms, this actually just means you can define attributes that are ignored when you're checking for a match within a certificate. This once again also allows for a more fine granular control over certificates that should be used in the matching process. Last but not least, with our Q3 release, we enable identity provisioning for SAP HANA Cloud, SAP HANA Database via identity authentication services. With this, you're now able to automatically provision users, which makes the process definitely more efficient and less time-consuming. So, last but not least, for the general section of this webinar, we're offering a new Google Cloud Platform data center within the Kingdom of Saudi Arabia. This improves the availability of data centers of your choice in the Middle Eastern region, so you can definitely pick and choose the hyperscaler data center of your choice. Last for my part of this webinar is a personal recommendation, not an innovation, but a great event. Virtual TechEd is just around the corner, and we from product management are featured in a few sessions. So let me recommend to register for this great free of charge event if you want to get deeper insights into HANA Cloud, if you want to get hands-on experience with our product. Definitely register for these sessions listed on the slide here. You can just register by scanning the QR code on the slide. And with this, I'm actually already handing it over to our first expert, Rob, for the support for PrivateLink on AWS.
Thank you, Susan. So yes, I get to talk about our support for PrivateLink, which is a long-awaited feature for HANA Cloud. This release for QRC3 is our initial support for PrivateLink. It is going to be available on AWS only at this point. So all HANA Cloud, all the BTP connections rely on what's referred to as a public IP endpoint for client connections. Those connections are always secure by default. All BTP services, all HANA Cloud services require and enforce the use of TLS encryption for all network connections. On top of that, you have the ability to filter or specify and allow this filtering, which reduces the inbound connections that can actually see and access that public IP endpoint. What private IP endpoints do is they add an additional layer of protection to your connections. So with a private IP endpoint, on the client side, you actually configure an alias, an endpoint alias within the virtual private network of your application. And then on the HANA Cloud side, which is the work that our teams had to do and is delivering now, within the HANA Cloud, we have to register the HANA Cloud instance, in this case, the HANA database, to act as a server-side connection for that private IP endpoint connection. So again, the initial implementation is supporting HANA database connections only, inbound connections to the SQL endpoint using AWS PrivateLink. And here I've got an excellent demo.
Hello, and welcome to this short demo of the HANA Cloud PrivateLink feature. I'm Christian, and I'm going to guide you through the process of connecting a client application with a HANA Cloud instance in a secure way using PrivateLink. To start with, we already created a standard HANA Cloud instance in one of our landscapes, which we can see here. And we also created an EC2 instance in an AWS VPC. To see that everything works as expected, we now will create a standard SQL connection using the public endpoint. As we can see, it is possible to establish a connection, and we can also try some SQL, which also works as expected. Now we want to change the IP whitelist to prevent any external traffic from reaching our instance. To do this, we change to the UI and click on Manage Configuration. And after a few seconds, we can change to the Connections tab, where we change the setting to only allow IP addresses from Cloud Foundry in this BTP region. This will block any traffic from the EC2 instance to HANA, and in the end, makes sure that we definitely use the PrivateLink connection to connect to the HANA instance. We click on Review and Save, confirm the changes, and now we have to wait a couple of seconds until the changes are applied. If we now try again to connect to the instance, the connection should fail since the IP address of the EC2 instance is not whitelisted anymore. And as we can see, we can get an authentication failure. Now let's create a PrivateLink endpoint in order to connect to the instance. In order to create a new VPC endpoint in the AWS console, we first have to search for endpoints, and then we click on Endpoints VPC feature. Now we can create a new endpoint. Optionally, we can assign a name, and then we have to select Other Endpoint Services. Now we need to enter the service name. The service name can be retrieved from the HANA Cloud UI. Therefore, we again have to go to Manage Configuration. And again in the Connections tab, we can go to the AWS PrivateLink Endpoint IDs subsection and enable it. And at the very bottom of it, we see a list of endpoint service IDs. Here we only have one ID, and we will copy this ID and paste it in the AWS console. We should verify that this is correct. As we can see, we were able to verify this service name. And now we have to select our VPC. Now we need to select in which subnets the endpoint shall be created. In our case, it is sufficient to create it in 1A. We don't need a designated IP address. And next, we have to select the security group. And in our case, we have to select the security group of the EC2 instance. This is already the complete configuration of the endpoint, and we can create it. The endpoint creation usually takes 10 to 20 seconds to complete. In the meantime, we want to make sure that we can use the same DNS entry as before to connect to our newly created VPC endpoint. In order to do that, we have to define a private DNS entry which forwards any traffic to our public DNS entry to the private VPC endpoint. To do this, we first have to go to Route 53 and we have to create a new hosted zone. For the domain name, we choose the public HANA domain name without the service instance ID, and we have to make the zone private. A private zone has to be attached to a VPC. Therefore, we select our VPC. and create the zone. Now we can create a new record within this zone which forwards the traffic to the VPC endpoint. We want to forward any call to any subdomain to this VPC endpoint, and therefore we have to use the alias function. And we now choose alias to VPC endpoint. We again have to select the region. And now we can select the endpoint. And we only created one endpoint. Nevertheless, we see two entries here. There always is a global entry, which is not zone specific, and we see a zone specific entry. We will take the global entry. Now we will disable evaluate target health and create the record. Now any traffic which is sent to the DNS entry of HANA will be forwarded to the VPC endpoint. We can validate this by checking in the terminal that the HANA DNS entry resolves to the VPC endpoint IP. Therefore, use this command, and we can now see that there is only a single IP address to which the DNS entry resolves, and this is the IP address of our VPC endpoint. Now we are already done with setting everything up in the AWS console. Nevertheless, we need to whitelist the VPC endpoint ID in the HANA Cloud UI. Therefore, we go back to endpoints and copy the VPC endpoint ID. We will now switch back to the HANA Cloud UI and enter the just copied endpoint ID into the endpoint ID list. Therefore, we have to add a new entry here, paste the endpoint ID, and then save the settings. Now the VPC endpoint ID is whitelisted. Please be aware that it can take several seconds to be applied in the cluster, so you might not be able to immediately connect to your HANA instance. Back in the terminal, we can now try to again connect to our HANA using the same HTTP SQL call as before. And as we can see, we are now able to connect to our HANA instance. And we can also again execute SQL. Please be aware that it can be the case that you will receive timeouts during such a connection attempt. This is because your security group might not allow traffic to reach the VPC endpoint. If you encounter such issues, please go back to the AWS console and go to the security group of your endpoint and make sure that in the inbound rules, traffic to port 443 is allowed. If this is allowed, then the traffic should reach the endpoint. Now you have seen the HANA Cloud PrivateLink feature.
Okay, so as I said at the start, this is our initial release of support for private IP endpoints. At the moment, it's for AWS only. There are some limitations at this point. You cannot yet fully disable the public IP endpoints, right? So today, as I said, all connections to HANA Cloud instances go through those public IP endpoints. That includes supporting SAP BTP services involved in operations and monitoring for HANA Cloud. So we have more work to do to have all of the supporting services using PrivateLink, and that's a prerequisite to be able to fully disable that. that public IP endpoint. However, even today, when you use AWS PrivateLink connections, you can tighten up your allow list filtering to allow only IP addresses from Cloud Foundry within the BTP region. That does lower the visibility, further reduce the visibility of your public IP endpoint, right? But we know we have more work to do. Planned future activities, support for connecting to HANA Cloud Data Lake, both Data Lake Relational Engine and Data Lake Files. Using AWS PrivateLink is planned for, committed for Q4 release. Support for GCP Private Service Connect is just now committed for HANA connections for Q4 as well. And we are working on support for Azure PrivateLink, but that one is going to go into 2025. Right? And of course, we will be providing the ability to fully disable private IP endpoints for HANA Cloud services. So a good step. A useful step, I believe, but more work for us to do on this topic as well. So with that, I will hand it over to Jan.
Thanks, Rob. In the next 10 minutes, I would like to talk about new calculation view modeling features. The 10 minutes will not be enough to also show them in a live demo. So what I'm going to do is, or what's actually always available is, if you are going to the page about the new modeling features, then there's a link on the one hand side to a blog which explains again the new functionality, and there's also then a link to a project which gives you access to several examples and also a description about the individual functionality here. So for example, here you would have an example about frames in window functions. So what I will do now in the presentation is I want to highlight the individual functionality. And the first one that I want to talk about is the intermediate data preview in remote databases. The scenario here is that in a productive system, if you encounter some issues, some wrong data or failures somewhere, you would like to investigate that of course as fast as possible. The problem is you don't want that the user that is investigating these issues also has authorizations to change something automatically without further permission. So in the past, what we offered was to use a user-provided service that was using a user that has only the permission to do data previews in the productive system, but not deploy there. We enhanced that now with another option where we use the data preview with another database user to the same aim. So what you can do here is, if you configure a database connection with a database user that has certain permissions in a productive system, for example, only select, then you can use this user to do the data preview from another system. So to be a little bit more concrete, you can start, for example, in your development system or in your validation system, open your calculation view model there, then choose data preview with the other database user. And if you choose a database user that's pointing to the productive system, then you see the data as it comes from the productive system. But because you have the full control over the database user, you can control what this user is able to do in the productive system. So with that, you are now able very easily to start in your developer model to do a data preview in a productive system already. Now, obviously, there has to be a match between your model in the development system or validation system and the productive system. And the match is that the names of the calculation view have to be the same, and also the nodes that you want to do an intermediate data preview have also to have the same names. Now, the next functionality that I want to talk about are the graphical support of the structured filters. And for those of you who are familiar with analytic privileges already, will already know about this or know this UI pretty well. I mean, we basically support now structured filters with a very similar UI than we supported the analytic privileges. What we added for both now, for analytic privileges and for structured filters, is that we also show the common attributes that are common to all models that you have here in the secured area, which means here you easily see now which columns are available in all models, so that you can easily define your restrictions based on these columns that are available in all models. I highlighted before quickly about the window function frames. We enhanced the window functions by the option of frames. And a frame is a way of specifying another context within a window partition. So for example, you can define that if you calculate a certain record, which other records should be included in this record. In this example here, you would see unbounded preceding, which means you would take into account all records that come before a certain record, and you would then also take all records into account that come afterwards up to a certain value that's given by an input parameter. So for example, if you want to do a sum over the of all records that come before a certain record and of one record afterwards, then you could use this setting. So you would sum up all preceding records, and you would sum up then until the input parameter value of that you enter then perhaps 1, so that you would take one more row into account afterwards. So this gives you a lot of flexibility in evaluating window functions using an additional context. We, in a scenario when you add a column to a table, for example, you often also want to make this column available in the output of a calculation view. For this functionality, we offered already an option called propagate to semantics, which meant if you had a column added to a table and you went to the mapping dialog and used this functionality, then this column was propagated up to the semantics node, meaning it would appear in the output of the calculation view. So this way you can easily adapt your calculation view to newly added columns. Now, sometimes it could happen that you added a column name that was already used somewhere in the calculation view, and that led then to a naming conflict. We offer now a flexible resolution of a naming conflict. So if a naming conflict in this propagation of a column is detected, then you see a dialog which asks you how this naming conflict should be resolved. For example, whether you want to add simply a number after your column, or you want to include the source name or some free text or whatever. So in this way now, you can easily resolve potential naming conflicts if they arise during the propagation to the semantics. The propagation to semantics can also be used to propagate a name change of a column. So if a column is renamed and you just want to propagate the renaming of the column up to the semantics node, then this dialog could also be used. In these situations, we don't offer this option to make it unique, because if you rename a column, the assumption is that you really want to have the renamed column also added. So we don't do any conflict resolution in that case, but simply stop propagating. If you wanted to change your models, for example, you want to delete a node in between other nodes, then in the past, you lost the information about the mapping of the previous nodes to the following node. Now we offer an option where you can then select which source you want to map to the target node. So for example, if you delete here the join node, you would get a dialog asking whether you want to keep the mapping from projection 1 to the aggregation or from projection 2 to the aggregation. And depending on your choice, then this mapping will be automatically retained, and you get the mapping so that you have a functional model here without having to remap again after deleting a node. This functionality is not available in a multiple consumer pattern. So meaning if you deleted the node here, the join node, which is consumed by several nodes, then it's simply deleted and no mapping is kept. I think this is also a very helpful feature if you want to change your model slightly. So for example, you have made an aggregation node and at some point you realize, oh, you do have to do some pre-processing of the data source. Now, in this example, the assumption is you want to do a ranking before. what you had to do in the past is you had to create a new node, do a replacement with node dialog, and then get it somehow into the aggregation. With a new functionality now, you can simply take the new node that you want to have, for example, the rank node here, drop it on the data source, and you get automatically the data source wrapped in the rank node, and you have enhanced your model. As simple as that. If you are using query snapshots, then you are probably familiar with the functionality that we write you have an option to store the results of a query into a certain table snapshot table. And with the new release now, we offer an additional administrative function called selective deletion that's automatically deployed if you deploy a snapshot query, a calculation view with a snapshot query. And with this selective deletion procedure, you can define which data should be deleted from a snapshot table. For example, in this example, all data where the snapshot date is older than 10 days will be deleted. So what it gives you basically is a way of structured management of your data in a snapshot table. So you have a procedure that can delete from the snapshot table, and you pass to the procedure an expression that defines what is the deletion criterion. We offer documents that describe calculation views. So for example, what are the measures, what are the columns, attributes in a calculation view, or also what expressions are defined there, how do the filter expressions look like, and so on. We enhance that now so that you can generate the documents for all calculation views in certain folders. So you can select now on folder level, but also you can select individual calculation views, but multiple ones. In the past, you could only always generate a document for one single calculation view. Now you can select multiple ones and also on folder level. And the last one that I just want to briefly talk about is the option to copy restricted columns. So if you want to move a restricted column from a certain node to another node, we offer now also for these type of columns an option to copy and to paste. Obviously, restricted columns can only be pasted into aggregation nodes because that's where restricted columns can be defined. And with that, I thank you for your attention and hand over to Shabana. Thanks.
Thank you, Jan. Sharing my screen. And yeah, so to this section of what's new in the multi-model area, first we will talk about the update related to the JSON document store. So previously, as you guys know, JSON document store was schemaless or schema-free. So this flexibility now, I mean, in the past has allowed you to insert any document into a collection. So which was great if you were looking, if you are working with external data sources or evolving microservices. For example, it could be an online marketplace. One product listing could have a weight field, and another product listing like a furniture could have a dimension field. So there was no any constraint there. But here is a potential downside to this, like because there were no enforced rules, you had to make assumptions about data when reading it. So if you expected an ID field of big int, of type big int, it was and it was missing or incorrectly formatted, your application will have to deal with that. Or if you wanted to sum up prices, for example, a query could fail if the price field had a value like $5 associated with it instead of just having a simple number. So with this update that we are now providing, we are introducing the ability to define strict or mixed schemas. So what does that mean? Now you can actually define rules or schemas that your JSON documents have to follow. you can enforce the structure on the documents, meaning you can say things like these specific fields are mandatory, or this field must always be a number. For example, you can see on the right side of the screen here that you can set up rules like the order ID and customers down at the bottom or the required fields, while something like total could be an optional field. I have not mentioned it, but if it's included, I have set up a type constraint for that it must be always a number. So this gives your data some consistency and validity out of the box. The schema rules ensure that your data stays clean and you don't have to worry about dealing with messy, inconsistent JSON. And it doesn't just stop there. These rules can be enforced not just when you're inserting or updating the data, but also when you're querying, like using your select queries. So the database will make sure that the data type is respected across the board. So just for an example, like say in a financial app that needs every transaction to have an amount or transaction ID, with schema flexibility, there was a risk of there might be a risk that these errors could come up if some of the fields are missing. But with JSON schema, you're enforcing these fields and ensuring that the data remains clean and you're adhering to the rules that are provided. So how you can basically use it, it is very simple, just like as using the create collection. Like you see on the syntax here, you can define the schema and specify the rules. And if you ever need to adjust your schema later, you can even modify it using the alter collection statement. So that's a quick round there. And I think I'll go directly into the demo to show how that all works. So at first, let's see that I'm going to create a collection called orders, and I am already setting up some rules what the document collections should follow. Like I am setting up the order ID and customer properties to be required, and I am keeping my document store a little bit flexible because I want to add additional properties at the later point in stage. So let me just run this script and see that I have now created the collection with a particular JSON schema. There are also other options that you can see on the help portal. We have multiple schemas that could be associated with your collection. So I've just used one of them. And now you can take a look at the schemas that you create on your JSON collections using, taking a look at the M collections table as I have just done here. And then on to the next one, let me just insert some details into that JSON collection. I'm inputting the order ID, customer, and total properties. And we can view what we have just inserted. So 5 records. And now I'm wanting to involve more records into my document store. I'm going to involve 2 more records, which has an optional property that's coming in. That's I'm going to input currency as USD. I'm going to insert this record, so that should be fine. And when I query that there are any records that has the field currency, I have the 2 new records that I've just inserted. So coming to the validation perspective now. So in this particular insert statement, I am trying to insert an order ID, which I am giving in the form of string, and it should not accept this because order ID should always be a number or a big int, like what we have specified in the beginning. So you can definitely see that we get a schema validation error because expected type is integer, but I'm trying to input the string. Similarly, now in the next step, I'm trying to omit the order ID altogether, and I'm trying to insert a record now, which should not be happening because order ID is a required field in my collection. So yeah, as expected, so the required property order ID customer is, the order ID is missing, so I'm not able to insert those records. So yeah, that's a quick look on how these JSON schemas could be very efficient in keeping your data consistent and adhere to certain rules. Back to my slides. Yeah, so the next feature in the multi-model is in the area of vector engine. We are introducing vector index. So this feature is designed to solve a very specific requirement while performing similarity searches. So what is the challenge at hand here? So previously when SAP HANA computed similarity between a query vector and each vector in a column, it had to compare every single vector. So this meant that CPU usage was directly proportional to the number of vectors in the column, which made the process a little bit resource intensive. So the more vectors you had, the longer and more costly these similarity searches became, specifically for like when you're dealing with large data sets. So to solve this, we are introducing the vector indexing concept, which accelerates the top K nearest neighbor, nearest vector neighbor queries and reduces the CPU load. So by creating an index on the vector columns, you can significantly improve the query times and also the amount of CPU resources that is required. And HANA now also supports this for the vector indexing. We support the hierarchical navigable small world indexing algorithm, which is widely recognized for being one of the most efficient in the approximate nearest neighbors benchmark. To just give an additional context here, most of these approximate indexes, even including HNS-W, offer parameters to configure the accuracy of your index. So with higher accuracy, you might see sometimes you might see longer index build times, more memory usage, or slightly higher query times. But you get a better precision with it. So it's up to you to balance the speed and accuracy based on your requirements. And we have provided, the parameters to adjust it, which we will see and discuss in the syntax and demo as well. So basically how to enable the vector indexing, you can create or drop or rename a vector index using the SQL statements, simple. And when you create an index, you need to specify the similarity measure, like it could be cosine similarity or L2 distance, that the index will be based on. And you can only have one index per similarity measure on a vector column, but you can have multiple indexes for different similarity measures. For example, you can just have one index for cosine similarity and one for L2 distance, but you cannot have two indexes for the same similarity measure at the same time. So once the index is built, it will automatically be used in compatible similarity searches. And if you ever want to bypass the index for, to get better results or exact results, you can use the hint, like the no vector index hint, to suppress its usage. Okay, so on this slide, just a quick look at the syntax. As you can see, we have the create vector index syntax mentioned in the beginning. So this command creates the vector index on a specific column of a table, and the index is also tied to, you can see, a particular similarity function that you can mention here. It could be either cosine or L2. And we also specify additional configurations, like with the build configuration. For example, you want to tweak the accuracy of the index. You can adjust the parameters that influence the index build time and the memory usage on this section. So just talking about the benefits, so you will definitely see efficient similarity searches, improved query performance, and optimized resource usage, as we have been talking, especially when you're dealing with high dimensional vector data, or large data sets of vector data. To just get an example on the performance, I just inputted some screenshots here. As you can see, when I have already built an index on top of a particular table, and when I am just running the query, it is automatically taking into consideration the vector index that I have built. And you can see that the memory consumed here is very less compared to when I am running it without the indexes. So I think that's a quick look at this screenshot, but we can also have a look at the demo in depth. So I'm going to create an index on a table that has around 1,000 odd vector data. This is a Marver characters table. So let's see how many of the rows that I have. I have around 1,170 rows, which is literally a small table just for the demo purposes. So let me create an index called Marvel IDX on the Marvel characters table, and on the column name vector. And I'm going to be using it for the similarity function cosine similarity. And I have configured the build and search configurations to be at the default levels so that I keep it optimal. Okay. Okay, looks like the index was already existing. So let me just drop it off. And yeah, exactly. So I'm going to create the index back again, just that you see that it get executed. And now let me run the top similarity search. I'm trying to find all the similar vectors to the field, to the vector field that I have given here. So when I run it now we are considering the vector index in place. You can see that the memory consumed is very low, and also the time consumed could also be very less. And then when I'm going to suppress the hint, suppress the vectors here with the help of the hint, you can see that we have consumed a lot of memory, and also the time also has been more than what we did in the previous step, like the previous one when this one was considered. So it has been significantly less this time. And you can also take a view at all the indexes you have created for the vector by looking at the vector indexes system table view as well. So I have just one index that I just created. And you can see the list of all that you create at the later point in time as well. And I think with that, I will hand it over back to Christoph. Thank you.
Thank you very much, Shabana. Let me continue. All right, so let's have a brief look at the machine learning AI functions update in this release. Our release highlights are first and foremost a new clustering function called HDB scan, hybrid density-based clustering. It's basically a variant of a very popular algorithm which we already provide in the predictive analysis library, but it kind of adds to be more robust, as it has the ability to build clusters of varying density. So it's more robust if your data is more diverse. And a highlight is adding onto the topic of working with vector data is that HDB scan and DB scan are the first two functions in the PAR library which allow to process vector data. So we can basically use those functions to identify clusters in the respective vector data Shabana has just shown, for example. Additionally, there are two new functions in the area of AutoML and machine learning pipeline. Basically, a feature which allows to use the AutoML engine and execute it in parallel on subsets of your data, which you identify by a grouping column in your data you want to analyze. We'll see that in a second, also in an example or screenshot here in the slides. We also have additional enhancements here for our multitask neural network algorithm, which we introduced in the last quarter. It has been improved for more robust and deeper neural network models, certainly providing even better outcome with using the ResNet neural network algorithm type, or allowing a batch mode, which then would train the model on the complete data set you provide to the algorithm. Also, our algorithm in the time series areas, long-term time series forecasting, is now enhanced with a feature which embeds data normalization before the time series model is trained, which again yields to more robust models with respect to changing mean or variance in your time series data. The automated predictive library is also available in a new version, 24.13, in this HANA Cloud release. We always provide this overview slide, which adds the new functions here, so you get a complete picture of all the algorithms we have available in the predictive analysis library. So now looking at an example of the vector data clustering. So imagine here on the lower left side, we see a table called HANA Vectors to cluster with some vectors which Shabana has just created. It's a different use case we see here. But then as you see on the right-hand side, we can just use the PAL functions PAL_HTTP scan and identify respective clusters in this data. So pretty simple. We need to provide some parameters to the algorithm, but it's pretty easy to use, and especially the HTTP scan provides better and more robust density-based clusters it can extract from your vector data. Now again, looking at the AutoML and pipeline modeling features, as mentioned, we now allow to develop multiple models in parallel using the AutoML and pipeline engines with these new functions, which we call massive functions, PAL massive, AutoML, fit, predict, score, etc. for all the different use cases. When you build machine learning models, there's a new functions. And as you can see here on the right-hand side, you hand in your data set, which has this grouping column. You have this single call where you want to open the AutoML processing, and the engine parallelizes behind the scenes in parallel. Actually, this data parallel time series forecasting or machine learning is a very common pattern with our SAP stakeholders leveraging our time series algorithms, like, for example, integrated business planning and others. There's almost always a data parallel pattern in time series forecasting. So if you now want to apply AutoML to time series, you can stick to this pattern and run the AutoML time series in parallel. If you are already familiar with the AutoML use of the predictive analysis library, there's a new parameter verify config, which allows you to verify your custom AutoML configuration before you actually execute and run into errors. So also very helpful new capability. Then our Python machine learning client for the data scientists not working with SQL, again, provides a rich set of enhancements, like, for example, our massive data parallel interface to the AutoML function, as you can see here on the right-hand side, is already supported. Also, our multitask regression and classification neural network algorithm, which we have seen on this slide before, is supported in the Python machine learning client. And a set of other enhancements like outlier detection for regression models. What else to name here? For those who are familiar with SQL Alchemy in Python, can reuse the connection context and work with both basically in parallel in your project. Machine learning models can be enriched with a model card, basically a metadata report on all the information which is available about your machine learning model. Also very, very helpful. I'd like to finish briefly with some hints to, first and foremost, our blogs, which summarize in detail all the enhancements, the overview block, new machine learning features in HANA Cloud, and then the one specific for the Q3 release, new machine learning features in Q3, giving you more details and examples of what I've just talked about, including at the end a link to an example in our sample repository, so you can basically try out all the new features yourself, for example, using a Jupyter notebook and this Python example. And allow me one quick example on one of the new features here. We have sales data on two products, classic shampoo and new shampoo. And we see we have a grouping column product here. And what we'd like to do now is train time series AutoML models in parallel. So we use the new function massive automatic time series. And as it's running, we see 7 seconds. It, in this case, as we can see from the parameters for each of the time series, tried about 30 time series. And then we get the results for each of the product groups. It calculated, or it's giving us the 3 best models. And as you can see, it tried completely different time series algorithm on the data, coming up with the best ones, certainly also providing us with the statistics here on which are the best algorithms and why. And with that, I'd like to close and pass on to Volker. Thank you.
Yeah, thanks very much, Christoph. So I'm just sharing my screen. So we have one sample here where we're going for the database explorer, and we introduce here AI. So you see in the first column natural language, and that's converted here to a table. I'll show that in a moment on a video. So we have that in the next bars, which is coming out next week. So you can then try that on your own. So come on. So you type something into your natural language, then you choose you want to write a prompt here. So it gives you now, it knows the HANA syntax for expensive statements, and then you can execute the line itself. So it's totally interactive and depends on what kind of run conditions you give it, what you get out of this. So another ask is, what is the current user using? So which tables are belonging to him? So you get this one here. So this helps you in your SQL console. The next thing we introduce is a so-called notebook. So you just saw the Jupyter notebook, and I will go to my own notebook now. So we have now notebooks as well in our environment. So rather than we have Python and some SQL inside it, we are now allow to execute directly the statement here without any Python, which you have to handle over. Your connection management is here, and I can run one after the other, and I'm seeing the results. I can redo the results if I want. I can clean the results, and now come on, go here. So I can clean the output. I can give it various formats here. Play around with it. It's already in your tooling these days. Documentation is out now with the new version. I hand it over to Dan.
Thank you, Volker. Let me just share my screen quickly. So my name is Dan Van Leeuwen, and I'm going to very quickly show a few more tooling enhancements. And to do so, I'm going to just jump into a very quick demo. So I have my HANA Cloud Central open here, and the first feature that I want to talk about is the statement library, which is in the SQL console. So I'm going to open up my SQL console, and maybe I've got a statement here that I frequently execute. And you can see that there's now an option to save the statement, and I can give it a name, give it a description. So this particular query is just going to show me the different hotels that are located within New York City. And you can see that it's now been saved. I can jump. Now we have this little toggle in the SQL console that allows us to switch between the editor view and the statement library view. And I can see my new statement that I've saved into my statement library, the time that it was saved. I can see that it's a user statement as opposed to a system statement. System statements are coming from the HANA database metadata view. So they contain interesting statements such as, the list of connections or the connection attempts and status. And also it saves if it was a data lake relational engine or a SAP HANA Cloud database type. Once you have some statements in your statement library, if you wanted to export them, you could come down to the export and export a collection of these and pass them off to a colleague. And similarly, you can import statements into your statement library. Okay, the next feature that I'd like to quickly highlight is within the Database Objects app. So the Database Objects was a new feature within QRC2. We've continued to enhance it and add new features. So we've added some more object types. We've added remote sources and graph workspaces. We've also added a setting. So if I go to my settings app, I can control, we now have an entry for database objects. and I can control the different objects that are shown in the database objects app. So I can further filter down into or focus on what the objects that I want to see. And I can also, for example, change the order of these objects. So if I wanted to just have tables show up first in my view, then we'll make that change now. So I can see that I now have tables first. We've also added a favorites. So I can go to my favorites list here, and I can see a list of objects that I've said are my favorite objects. So for example, I can go on to this hotel object. And the way that you toggle a favorite object is by this little star here. I can toggle it to make it a favorite or not a favorite. And I just want to point out that there is a filter here, so that if I wanted to look for all instances rather than just the current instance, or I can say, just show me favorites for this particular instance that I'm on right now. That would just reduce the view a little bit. Okay, and then the final thing that I want to very quickly mention is that for a data lake relational engine, we've added a new card for consumption. So similarly as what we did in QRC2 for the HANA Cloud database, we've added a consumption monitor for your data lake relational engine. And with that, I would like to pass it over to Susan to conclude.
Yeah, thank you, Dan. We're quite short on time, so let me just say a quick thank you to all our experts with all these great innovations that we just delivered with the QRC3 release of SAP HANA Cloud. As mentioned in the beginning, this is not everything. There is more, so make sure to check out our technical documentation as well as our comprehensive blog post in the SAP community. And with this, thank you for joining us today and have a great rest of your day.